Hello! In this video, I'm going to describe working with graphs in our vibration control software. And I'm going to demonstrate it on the example of sine test. The only difference from the other vibration test here is the specific graph types. The principles of working with graphs will be exactly the same for all tests. To start work with the graphic subsystem of the program, press New on the graph panel of the ribbon. And here we can see the graph settings. First of all, we can choose graph type versus time, versus frequency, oscilloscope, or other. After we have determined the graph type, for example acceleration versus time, we can enter graph settings. We can edit the graph name, enter the one you like, change the background color, show or hide log over here, change grid color or disable the coordinate grid. Tracking mode is enabled with this checkbox. In this case, you will not see the whole graph window, but only the current segment of the graph, and it will move along the axis as the test progresses. For each axis, we can enter a name. Autoscale is enabled by default, so the system will change the data on the axis depending on the current values, and you can see the whole picture. We can choose linear or logarithmic scale. We can select the lines we want to be displayed on the graph. Those lines are channels and some additional lines, which may vary depending on the graph type. For example, for acceleration graph, we can show task, response, tolerance, and abort level. For the THD graph, there are no such lines, and it is shown only for the channels. For drive voltage graph, the channels are disabled, and only drive voltage is shown. After that, we can assign color to each line on the graph and choose line type, regular, bold, dashed, or dash dotted. We can also arrange to display several graphs in one window. To do that, select the number of the graphs to be displayed in the number field, 2 or 3, and then switch between graphs with these points to set up each of them independently. The first may be acceleration versus time, the second, velocity versus time, the third, displacement versus time. We can also choose graph's position relative to each other, vertical, horizontal, or T-shaped. I will choose T-shaped. So we have set up everything, and now we can press OK. T-shaped position means that one graph will be in the left part and two others in the right part of the window. We can also create a default graph. To do that, we press the arrow button here below, and we see a drop-down window with a list of options. Let us select phase versus frequency, and we can see the graph with default settings. If we'd like to change some graph settings, like delete or add lines or change the scale type, right-click on the graph and choose Settings. Here we can change any graph settings except for the graph type. For example, I want to fold test log. I press Apply, and here's what it looks like. Now let us bring the log back. Now I want to change the scale type on the horizontal axis, the frequency axis. I set linear scale, press Apply, and we can see that the scale is linear now. When you click on the line's name on the graph, it becomes bold. Click on the name, channel 1. It is a red line here, and we can see it is bold now. After that, I can copy this line to any graph which has frequency on the horizontal axis. To do that, I press Ctrl+C key combination. So I copied the line to clipboard. Then I select the frequency versus acceleration graph and press Ctrl+V. And you can see my channel on this graph. It appeared here. Mind that it is in displacement units, even though the graph is frequency versus acceleration, but we copied the line in millimeters. I can also delete the line in the same way. The edit line is marked with a star. Highlight it and press delete. Another thing we can do is export a line to CSV format. It is the format of Microsoft Excel or OpenOffice Calc. I can highlight the line and press Ctrl+E. In this window, we specify the name of the file and the path to it. Let us save it to desktop. And now on our desktop, we have an Excel file with the values of this line exported to it. If we want to expand some graph to the full screen size, we can press Expand, a standard Windows button. If we are adding a new graph, for example THD versus frequency, and we want to see all the graphs at the same time, we can press Arrange on the View panel and choose one of the 4 options. Vertical arrangement, horizontal arrangement, cascade, and the most convenient type, adaptive. The system adjusts to the current number of graphs and screen size in order to give the best possible display. The Arrange panel works for any number of graphs. As a matter of fact, the system has no limit of the number of graphs you can open. 5 or 1 or 10, it is totally up to you. Now I'd like to tell you a little more about the context menu on the graph. A right-click on the graph field calls the context menu. The first point of the menu is Autoscale. If I highlighted some graph segment to have a closer look, I now need to return to the normal size of the graph. So I can right-click and press Autoscale. The Clear button deletes all the channel's data. The Settings option calls the graph settings. We have already talked about it. Another context menu option is Save. When we press it, we can save our graph in BMP format as a picture. And after that, we can paste it to a report or print it out. We choose the path, enter the file name, and press Save. The next option is Print. We can send the graph to be printed without saving it to any file. Here we select the printer and press Print. We can also edit the printing settings, change the printing formats, add visual effects, so it works exactly as a standard Microsoft printing window. A few words about cursors. There are several types of cursors in the software. The first is Current Data Cursor. If we select it, we get a vertical cursor showing us the current value on the horizontal axis. Now it is frequency. You can see the current frequency value. It has 3 digits after the decimal point. The cursor shows all the data in its range. To give you a better display, I will choose another graph with more data. For example, THD versus time. The number of lines shown on the cursor has changed. We have only 4 lines, 4 active channels. So when I move the cursor, I see the values of THD on each channel at any point of time. To disable the cursors, select the option from the menu for the second time, press it, and it is disabled. Then there's the second cursor type, a cursor line. To enable it, press Add Cursor Line. And we see the cursor and all the data along the line in the corner. We can move the cursor line holding the left mouse button. And we can add a few cursor lines, 2 or 3. When we place those in different positions on the graph, we can get all the data we need. To delete a cursor line, press Cursor and choose Delete Cursor Line. If we want to delete all cursor lines, we press Cursor, Delete All Cursor Lines. Another thing we can do is adding some points to the graph. It is also done through the cursor menu, so choose Set Points option in it. In the lower left-hand corner, we can see the coordinates. X is frequency, Y is acceleration in G. Choose the place for our point and click on it. To the right, we see the coordinates of the point. We can set a few points. They will be numerated, and each one of them will appear on the log with its coordinates. To delete a point, click on it on the log once. A red dot will appear next to it. Then you click on it once again, and the point is deleted. We can also add nodes to the graph. We select Nodes option of the menu, press Add Node, and here we can enter the text of the node. We can attach the node to the graph or float it. Let me explain the difference. If we do not attach the node, when I start scaling the graph, zooming in or out, the node is always at the same place, somewhere at the center of the screen as I placed it. So it is not connected to the current graph coordinates. Now if I create another node and fix it, you will see the difference. The node stays in the same place relative to the lines of the graph, so it is fixed in the absolute graph coordinates, while in the first case it was in the relative coordinates. To delete a node, right-click on it, choose Nodes, and Delete. One more option is to add a parameter. Choose this point, and here we can create a template for the parameter. The parameter is the value on a channel, task, response, frequency, or data channel, and the dimension we want displayed during the test. Here we also specify the number of digits after the decimal point. Let it be 3. And I want to see the value on the first channel and its current acceleration. Now the test is not started. If I start the test, we will see that as the system starts up, the value on the channel is increasing. It reflects what is shown on the response panel, as the first channel is the control one in my current configuration. I can add another parameter. Let it be drive voltage. And here we can see the value. So we can follow the relevant parameters right on the graph, and we do not have to get distracted by any panels. We can place such a node with a parameter at any point of the graph, and they are fixed to the relative coordinates, so when you scale the graph, they are always visible. The next parameter is grid lines. We can add more coordinate lines if the existing ones are not enough. For example, if we want to save the graph and demonstrate something. Vertical and horizontal lines can be added. So we choose vertical and see a vertical grid line which follows the cursor. When we click at a point on the graph, the line stays in this position. It will not disappear if you scale the graph, and it has the corresponding coordinates on the axis. The same thing with the horizontal lines. I pick horizontal and add one here and here. To escape the grid lines mode, choose the corresponding menu option. You can either delete the latest grid line added, you see it disappeared, or delete them all if you do not need them anymore. The last option of the menu is Copy. As we press it, the graph is copied to clipboard exactly as it is now, and we can paste it into a text file of doc format or any other. So we do not save the graph file to BMP, but just paste it directly where necessary. Now if we want to highlight a graph, for example, we choose Cascade Arrangement and we cannot see some of them, we press Graphs button on the View panel and select the graph we want to see on top of all the other. Let us arrange them again. I'd also like to note that the task line is always shown on the graphs versus frequency. On the horizontal axis, you can see the extreme points of the task, or the extreme points of your profile. They are shown in green here. They disappear when you scale the graph, but when you press Autoscale, they reappear again. It is very convenient if the profile extremes are not round numbers, they are not on the coordinates. But with this option, you always know what profile you are running. This was a brief introduction to the graphic system of ruler vibration controllers. Thank you for your attention, and goodbye.